In the 1980s, American navigation happened in the glove box. People navigated by unfolding massive, overlapping paper maps and tracing routes with a finger. At the time, there was no unified digital map. State agencies, the military, and private companies all maintained their own disconnected datasets. These systems used different standards and couldn't communicate with one another. This lack of standardization was a crisis for the U.S. Census Bureau. Every decade, the Bureau is constitutionally required to count every person in the country and record their exact location. To count accurately, they needed to know where place actually was, but they lacked a central database that could universally define the coordinates of every road, property line, and intersection in the nation. Relying on thousands of conflicting paper maps at a national scale was a computational impossibility. The Bureau realized they had to throw out the analog charts and build a digital geography from scratch. The solution began in rooms filled with mainframe cabinets and tape drives. However, the Bureau's engineers first had to solve a conceptual problem. They realized they couldn't simply draw a map on a screen. Computers can't read a picture. They had to encode the physical geometry of the entire country into a strict relational database. This task required an immense volume of human labor. Technicians spent years digitizing and encoding physical boundaries from drafting tables into raw digital data. The system they built had two parts: the master address file, which held the house numbers, and the Tiger system, which handled the spatial relationships between features. This combined database created the first invisible spatial backbone of the nation, operating years before the first commercial GPS systems hit the market. Tiger succeeds because it relies on topology, the strict mathematical relationships between shapes. To build a map this way, you start with nodes, exact starting and ending points on a coordinate grid. When you connect two nodes, you create an edge. These edges represent physical features, like a local road, a state highway, or a river. When edges form a closed loop, they create a face. These polygons represent the boundaries of city blocks, census tracts, and counties. Finally, Tiger assigns address ranges to the edges, recording which street numbers belong on the left and right sides of a segment. By linking these elements mathematically, Tiger allows a machine to solve complex relational problems, like identifying intersections, where a simple image would fail. When you type a street address into a search bar, Tiger's architecture translates that text into a physical location on the grid. The system first standardizes the text, normalizing abbreviations and directional prefixes, before scanning the database to find a matching street edge and city. Tiger uses a process called interpolation to calculate the distance. If a street segment is numbered 100 to 200 and you search for 150, the system places a coordinate point precisely in the center of that edge. Once that point is dropped, the system checks the underlying faces to determine the address's wider hierarchy, from the census block up to the state level. Tiger does not track individual homes or people. Instead, it uses mathematical estimation to fill in the spatial gaps across the entire country. The American landscape is in constant flux. New subdivisions are paved and old roads are rerouted every day, making static maps obsolete almost immediately. Tiger fights this decay by ingesting massive volumes of data from the Postal Service, state transportation departments, and local municipal registries. This information is cross-referenced with field workers who verify addresses on the ground. Complex algorithms then merge these sources to ensure the database stays current. When these updates fail, a topology error occurs. A microscopic gap between two nodes can cause a navigation system to fail a route or place an address in the wrong block. Because of this constant change, Tiger functions less like a finished file and more like a living industrial engine requiring endless maintenance to remain accurate. Eventually, the technology developed by the Census Bureau expanded into the consumer and political sectors. As the only comprehensive digital map of the country, Tiger provided the foundational layer for early digital navigation and car-mounted GPS units. It also redefined how the nation handles its politics. Legal district borders are encoded into Tiger as interconnected polygons that must align perfectly with existing census tracts. While the database doesn't choose who wins an election, its exact geometry is what makes modern computerized redistricting possible. This specific data structure has become the standardized blueprint for how American society organizes and governs its physical space. While private tech companies now use their own mapping fleets, the logic of their systems, the nodes, edges, and address ranges, was established by Tiger in 1990. Tiger is the invisible ghost beneath the polished interfaces of the apps we use to find our way every day. The Census Bureau built this system to count people, and in the process, they drafted the digital blueprint that defined the shape of modern America.